All right, so remember it was only 3 out of 400 times we've gotten the value we got, or something more extreme, given that this is actually the true proportion. So that means that it's very unlikely that if he really could shoot 80% at the line, right here, this 80%, that he could have gotten .64 or something worse when we took them down to the gym to do it. Based on the evidence, we might conclude the player's claim is incorrect, right? Because it's not very likely, and it couldn't have, we're going to say it probably didn't happen just by chance alone. In reality, there are 2 possible explanations for the fact that he made 64 of his free throws. Okay, the player's claim is correct, and just by bad luck, a very unlikely outcome occurred. Okay, he just had a really bad day. Or 2, the population proportion is actually less than 0.8, so the sample result is not as unlikely of an outcome. Right? So we're saying it's not really here, it's down here, so what we got really wasn't unlikely. It's actually more reflective of what's really going on. The basic idea is that an outcome that would rarely happen if a claim were true is good evidence that the claim is not true. So since this would rarely have happened, given that the null is true, the claim that they shoot 80%, is good evidence to say that this 80% not really accurate. A significance test starts with the careful statement of the claims we want to compare. The first claim is called the null hypothesis. Usually the null hypothesis is a statement of no difference. The claim we hope or suspect to be true instead, the null hypothesis, is the alternate hypothesis. So here we go. It's what I talked about in class. The null hypothesis is H naught, and then HA is the other. Now, actually, in your book, or for AP purposes, the free throw shooter example, our hypotheses are, okay, H naught, like it's always going to be equal. Like this is always going to be equal. The alternative can be the options I gave you in class, which would actually be not equal to, greater than, or less than. Those are your options for your alternative. Your H naught will always be equal to, okay, where P is the long run proportion of free throws made. All right. So the parameter equals a value, and the alternative forms are this. It's either going to be less than it, greater than it, or not equal to it. To determine the correct form of HA, read the problem carefully. Okay? So you're going to determine what they're trying to prove. Remember, what we want to prove, we state as the alternative. This is really what we want to prove. See right here.
Matt Quamby, please attend to the address. Matt Quamby,